Hello everyone, welcome back to the channel. As we know, Hamming codes is a part of digital electronics or digital communications, where here I will explain you how we can generate Hamming codes. This is very different case which I am going to consider here so that we will understand Hamming codes from all the dimensions. Right. Here the question is we have 5 bits of data, that is 0, 1, 1, 0, 1, to represent the given data in Hamming codes. Let's see the question here. So see here we have the given data with total number of message bits, that is k equals to 5 bits, which is given to us. Right. Now, our agenda is to identify how many parity bits are there in the given code. So, parity bits has identified with the basic relation as I explained in my previous lecture, that is 2 power p greater than or equals to p plus k plus 1. Over here k equals to 5. So we can say 2 power p is greater than or equals to p plus 6. So this is what the basic condition which we need to satisfy. Now we need to check all the possibilities. So I will check here. For p equals to 1, 2 power 1 is greater than or equals to 7. That means it is not satisfying the condition. For p equals to 2, 2 power 2 the greater than or equals to 8, that is not satisfying the condition. For p equals to 3, 2 power 3 greater than or equals to 9, it is also not satisfying the condition. For 4, p equals to 4, 2 power 4 greater than or equals to 10. That means it is satisfying the condition. We can take this condition. So, for this question, p equals to 4. So, now we identified that total number of parity bits are 4. Now we have an idea about the parity bits. So for p equals to 4, k equals to 5 and n equals to 4 plus 5 equals to 9. As per that, our code is 9, 5 Hamming code, where n is the total number of bits, k is the message bits. Now we need to represent 9 bit of Hamming code. Let me represent this. Make a notation as 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now our agenda is that what should be the position of the parity bits. What is that? Now what we need to find? We need to find the position of parity bits. As we can calculate, it has p1 is equals to 2 power 0, that means 1. We are having the first parity bit at the position 1, that is p1. Next one, parity bit 2 power 1, that is 2. At position 2, we are having the second parity bit, and for 2 power 2 we can write it as a 4. At position 4, we are having the fourth parity bit and 2 power 3, that means 8. At position 8, we are having the another parity bit. As I earlier told that we are having 4 parity bits and remaining all are data bits. Now we can write it as a D3, D5, D6, D7 and D8. Our next agenda is to identify the value of the parity bit. What is our next agenda? Our next agenda is value of parity bits. For finding the value of a parity bit, we will done by has check one bit, skip one bit, check one bit, skip one bit, check one bit, skip one bit. We need to do like this for the first parity bit value finding. What we need to do? Check one bit, skip one bit, check one bit, skip one bit, check one bit, skip one bit, check one bit, skip one bit and check one bit. What will get here? Sorry, it is 9. What will get the data here? D3, D5, D7 and D9. We will repeat the same process for the second parity bit. For finding the second parity bit value, we need to check 2 bits and we need to skip 2 bits. We need to check 2 bits, we need to skip 2 bits and we need to check 2 bits. We are not having the value, so we need not consider that. And what is the second value parity bit value? D3, D6 and D7. Next, the value of fourth parity bit is, for finding the fourth parity bit value, we need to check 4 bits and we need to skip 4 bits. The value of fourth parity bit is D5, D6 and D7. And last but not least, the parity bit value of number 8. For finding the value of parity number 8, we need to check 8 bits. That means we will get only D9 value. That is D9 only. Now, if you see our question, in our question, you can see our message data bits has 0, 1, 1, 0, 1. So I am writing over it here. That is 0, 1, 1, 0, 1. So now we need to identify P1, P2, P4 and P8. If you see P1 over here, we are having the data values as D3, D5, D7 and D9. To get the exact value of P1, we are going to XORing these all the data values. Has P1 is equals to, what is the value of D3? 1. And the value of D5 is 0. The value of a D7 is 1. And the value of a D9 is 0. By XORing these all, what will get? 0, because 1 and 2 ones are there. 1 XOR 1 is the result will be 0. So write it over here. What is the value of P1? 0. And for the next one, P2, what is the value of D3 is 1. And what is the value of D6 is 1. What is the value of D7 is 1. By XORing these three, we will get 1. For P4, we are having D5, D6 and D7. The value of D5 is 0 and the value of D6 is 1. The value of D7 is 1. By XORing these numbers, we'll get 0. Last but not least, P8. For P8, we are having D9. The value of D9 is 0. That means we'll get D9. What is the value of D9 over here? 0. So now we have P1, P2, P4 and P8. Now I can say my message sequence has my message sequence, that is 0 0 1 1 0 0 1 1 0. Did you understand what I said? This is the position of this is the value of a D9, and this is a P8, D7, D6, D5, P4, D3, P2 and P1. This is our message sequence of for the given 5 bits of data. This is what the Hamming code for the given 5 bits of data. In the next section, in the next section, I will explain you how we can detect and correct the errors from the given received Hamming code. To know it better, please subscribe our channel, like the video, share the video. I hope that you have understood the session over here. Thanks for watching.